go we're gonna go back to the lessons from previous year, which is Newton law of motions. As you can see that the block mass m1 is actually attached to the string on an incline which is about 30 degrees Celsius, 30 degree from the ground, and there is a friction, but that's not a friction, so the coefficient is given, which is 0.1. Mass 1 is very small compared to mass 2. Therefore, when we release the system, of course, block M2 will move downwards, and block M1 will slide up the incline with an acceleration. That's what you're looking for, and then you are tasked to figure out what the tension is. Once you figure out what the acceleration is, so I'm just gonna go ahead and show you the free body diagram of each one of them, okay? So basically we're gonna do it over here for the mass M2. There is two different forces. One is tension, the other one is M2G to be more precise. We're gonna use A is equal to 10 meters per second square. You know, as an acceleration due to the gravity for this one. And with this one, I'm just gonna go ahead and show you how to do this one over here. So mass M2, you know, first you have the force due to the gravity, and then when you do the algebraic, basically I have two different forces. One of them is actually M1G cosine 30. This one is M1G sine 30. That force of tension goes that way, and there is a normal force because, you know, the block is on the surface. And also when we also have the frictional force pointing this way, so I'm just gonna write out Fk. So we basically have 5 different forces for the block on the incline and 2 forces for the block on this one. So we're gonna go ahead and for this one, I'm just gonna go ahead and do this one first since it's easy. Sigma F equal ma, that's what we're doing for the sum of the forces. Since this one, since the motion is moving downwards, so that one has greater force and tension. Therefore, it will be M2A specific. So what we're doing right now is we're doing T. So it's gonna be M2G minus M2A. That's the force of tension. We're gonna have to substitute this in somewhere. Substitutes into, I'm gonna tell you what equation we're gonna be doing, okay? This one, we're gonna go ahead and do the same thing. Sum of the forces in the y direction first is equal to 0 since there's no motion upwards or perpendicular to the surface. So it's gonna be normal force minus M1G cosine 30 is equal to 0. Therefore, we can conclude that normal force is equal to M1G cosine 30. That's what it is. Then we apply the same thing for the x direction, which is MA. And this one is not equal to 0 because there is motion in the horizontal plane or parallel to the plane. So you have this force, so I'm just going to say T minus M1G sine 30, and also minus my Fk is equal to M1A. Now, you need to know that, you know, from our previous lessons, right, that the frictional force is equal to coefficients